Good morning, good morning, good morning. It is good to see y'all again. Welcome to the last 9 weeks. We are going to be starting to go back over some of the historical stuff we've already covered because we're starting to wind down for our STAR test. And I know that us needing time to review is something that I have to take into consideration. So I'm going to do a throwback to some of the stuff that y'all actually did really well on and try to make sure you guys feel confident going into the simulation that we're going to be taking on Wednesday. And then from there, we're going to continue working backwards through the nth term of a sequence. And this one we did the initial value, the rate of change, and the growth rate, and all that. And I was able to say, what is the 40th term of this sequence, or whatever the case may be. We're going to eventually get back to that, but I think we should start here where we had a lot of confidence and did really, really, really well. So let's go ahead and start here to start refreshing our memories on lines. Once again, we're going to be looking at a graph, and we're going to be looking for some of the key information on it, like the y-intercept, the x-intercept, the slope, as well as the zeros. A couple of things I want to focus on with this is that most of the time, these are going to be written as points, and so we need to make sure that we're familiar with being able to put a set of parentheses with some numbers and such in the middle, like that, okay? So let's go ahead and get started on filling in these notes. Okay, so the first thing I want us to talk about is going to be our intercepts. So the first one I want to talk about is our x-intercept, and the x-intercept is important because, like you guys saw with the quadratics, it's where it crosses the x-axis, and that was something that we called the zeros. So you see that a lot more when it comes to the quadratic graphs, but it is something that can be mentioned here. I know I've called it a zero right now, but something else that we could call it is a solution. Remember how when we did y equals 0, or excuse me, 0 equals x squared plus 2x minus 3, or whatever the case may be, and we were able to say what the zeros were and the solutions were for that, and we had to start where y was equal to 0. Well, that's the same thing that would happen on a linear equation. You're still going to be starting with an equation that you would then be able to say, where does y equal 0? And you might see it where 0 equals blah, 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 blah. And that's why it's called a solution. Now, an ordered pair has that 0 at the y place. So that means you're going to have a number. And I'm just going to make one up. And I'm going to say that the y-intercept, or excuse me, the x-intercept is at 3, 0. And the reason that I would say 0 goes in the y place is because when you have a graph that you're looking at and you're drawing that line, it is going to cross through the x-axis all the way down here at the actual axis, and that is drawn through the 0 on that vertical y-axis. Like literally, if I'm counting up from -2, -1, 0, 1, 2, you'll see where this line goes through the 0 right there. And that's why the 0 goes at the y coordinate on the x-axis. Now, the other intercept I want to talk about here is the y-intercept. The y-intercept is the one that we're a lot more familiar with. And that one is one that we use when we're writing our slope-intercept equation. All right, this is where it crosses the y-axis, and once again, when we're crossing one of the axes, it always goes through the other axis at 0. And I say the other axis on purpose because if you're crossing the x-axis, then you have a y-axis that would be the other one, and that's where your 0 would be. Here, when it's the y-intercept and it crosses the y-axis, you're crossing the x-axis, and since that's the other axis, you know, the one that you're not using in that specific situation, it is going to be where the 0 goes. Now, the ordered pair, like I said, it goes in the x space, so you're going to have something like and again, this is an example, a 0, 3, because of the x having the 0, the y is the only thing that can have the number, and that is going to be something that is easy to forget about. Now, for each of these, you're going to substitute 0 in for the opposite value. Just like up here where the y value was 0, you're going to substitute 0 in for y and then solve for the x that's there. On the y-intercept one, you're going to take the 0 and substitute it in for the x, and then you're going to solve for the y value that we would end up with. You could also look at the graph and see where it crosses the y-axis. If it's ever at not a perfect point, you would have to actually generate the equation through a calculator, which we are going to be practicing as well today. In order to write the equation, you have to know the y-intercept as well as the slope, okay? So the slope describes how steep a line is. Once again, I get to draw, and when I draw this, you have a parent equation, and the parent equation is y equals x. When I have y equals x, my slope is 1, my y-intercept is 0. So it goes through the origin and just goes up 1, right 1, up 1, right 1, up 1, right 1. If I go y equals 3x and I was to redraw that on this graph, it's going to be a lot steeper because the slope is larger. If I wanted to shrink it, I would be able to do like a y equals half x, and since it's smaller than 1, that line gets a little more flat, okay? The slope is written as rise over run, so it is going to be counting up the axis and then to the side over the axis. Something we want to talk about is up and right. Those are both positive directions. Down and left, those are both negative directions. And so if we ever are counting 3 spaces down, we're gonna go with a -3 for that rise. And then the run, if you're going to the right 2, would be +2. If it's to the left 2, then it's another negative. So let's practice on these examples. I'd like to start on this first one where I can take these pretty points right here and I can just draw some dots and connect them. And I can count the spaces, a rise of 4, a run of 4. And I would write that as 4 over 4, and that is going to be equal to 1. And if you're not sure where I got that from, go to your calculator and put 4 over 4 into it. You'll be able to see that the calculator simplifies it to the number 1. Once again, we're looking for our y-intercept. There it is. It's all the way down there at the bottom where that -4 is. Once again, our y-intercept is a coordinate, and since it's where there's 0 for the x, we're gonna write this as a 0, and then that -4, that -4 for it being below the origin. From there, I can actually write my equation, and that is the next thing I'm going to do is write my equation. Y equals, the slope here is 1, x minus 4. Okay, so when I want to solve this for the 0 and I want to solve this for the solution, I'm going to take that y equals the 1x minus 4. You don't need the 1, it could just be y equals x minus 4. And I'm going to convert it to where that y isn't the letter y anymore, it becomes the number 0. 0 equals x minus 4. When I add 4 on both sides, I get x equals 4. And so I can actually take this and write my coordinate for it now, okay? X equals 4. My x-intercept is going to be at 4, 0. Once again, I want to put this in as a coordinate. Okay, from there, I'm going to also take that same thing and put it in as the 0 because the x-intercept and the 0 mean the exact same thing. Okay, from here, I've got that first one solved. What I'd like to do then is do the second one, which is, in my opinion, a little bit harder because look at the slope. Slope's a little bit bigger. If I go from here to here, those are 2 pretty points going from -1 up 4 places and right 1 to get to 4. That interesting information there about up 4 places, right 1, the rise of 4, the run of 1, I put that into the calculator giving me a 4. Plus, when I look really closely at this, I've got an y-intercept right there at the 4. Now, for that, because it is a y-intercept, I do want for this to be written as a coordinate. I'm not just going to add the number. The y-intercept happens where x is 0, so I get 0, comma. And then since we're going up to 4, I put a 4, and that closes that parentheses. I do the same thing when I start solving for the zeros from before, all right? I take my equation and I rewrite it with a 0 instead of a y. Hang on a second, I don't even have an equation. Yeah, that's going to be y equals slope x plus b, and in this case that's 4. So I get 0 equals 4x plus 4. When I subtract 4 on both sides, on the other side of the equal sign, I apologize. That gives me negative 4 equals 4x. When I divide by 4 on both sides, I get where x is negative 1. That I can then take to my x-intercept up here, and I can write in that negative 1, 0 is going to be my 0. Don't forget that it does need to go inside of the parentheses since it is an ordered pair. And then also from here, I'm going to do the same ordered pair where it is negative 1, 0. Okay? So that's going to be where those zeros come in. This next part is going to be a little bit trickier because you have to have an equation, or not equation, a calculator to be able to do this, okay? So it does take a couple of steps, but it is something that I have shown you before, and I do need y'all to be able to do it. This works if it's a table. This works if it's on a graph. This works if it's a ordered pair, or 2 ordered pairs, I should say. This is something that you have to be able to do. The graph of a linear function is it contains the points negative 4, 10, and 4, 22. So let's go ahead and find the equation of that graph. I know it doesn't ask for the equation, but we have to find the equation in order to find the x-intercept and the slope. So to do that, we are actually going to run to our calculator, where we go to the home screen, and we start by, the enter button doesn't work on this one. Gotta love calculators. I think this is the one that constantly turns off. We'll try it. Okay, so we're gonna go ahead and go to the green screen here. By clicking on it, we can then scroll up to the top where we're going to put the letter X here. From there, we're gonna look at our ordered pairs. We have a negative 4, that's going to be an x. We've got a 4, that's going to be our other x. So I run back to my screen, and I'm going to put those in the same order as what it does. The negative 4, excuse me, and 4. Then I go back here, and I push Y, and I move down. Once again, I run back to my screen, and I look and I go, okay, there's a Y and there's a Y. So I put my Y and my Y there. My 10 is paired with my 4, my negative 4, excuse me, and my 22 is paired with my positive 4. Okay, once I have this typed in, I get to press home, and I go 1 over to where it says data and statistics and click there. I'm not actually pushing the button, I'm swiping on it, and I put the X on the bottom, and I swipe over to this side and I put the Y here. That lines those dots up like that to where I can then press menu 4 because I want to analyze those dots. I'm going to choose the number 6. I know it says regression, but that's okay. And then 1, because you see where it says show linear y equals mx plus b. I don't want it to be in a plus bx. I want to get mx plus b because that's my slope-intercept form equation. So I'm going to push 1 to get that, and then I can see my equation, y equals 1.5x plus 16. That 1.5x is interesting because we would need to actually convert that to a fraction. So I take my y equals 1.5x plus 16 that I just got. And then I actually am going to run back to my calculator, or I'm going to go back to calculate, and I'm going to push 1.5, and then I'm going to be able to convert this to a fraction. Oh, that didn't work. I had hoped it would. Okay. So for this, there is a button, I don't remember what it is, for us to be able to convert it to a fraction. Give me a second to remember what the proper steps are. Menu, number, approximate to fraction, enter 3/2. There we go, that's what I'm looking for. By the way, the steps for that was pushing the menu button to and approximating it to a fraction. So a better way to write this is y equals 3/2 x plus 16. From there, my y-intercept is going to be at 0, 16. My slope is going to be at 3/2. Okay. And from there, I need to find my x-intercept and my 0. So I switch it to 0 equals 3/2 x plus 16. I minus 16 on both sides. And I get negative 16 equals 3/2 x, which I can then divide both sides by 3/2. And negative 16 divided by 3/2 is going to be something that I'm going to use my calculator for. Okay, I get negative 16 divided by 3/2. It gives me negative 8/3. We can keep it as negative 8/3, 0. Or if you want to convert that to a decimal, it would be Control Enter, and you would get negative 2.70. But honestly, it's most likely going to be given to you as a fraction of negative 8/3. But these would be the answers that we would look for here. And once again, we couldn't find our zeros or our x-intercepts without actually solving for the equation and then plugging it in. I'm going to have you go ahead and begin working on your worksheet from here. Thank you very much.